The emergence of life on Earth is a story of extraordinary wonder. It is a tale that spans billions of years, from a time when our planet was a fiery, inhospitable world. How did life, in all its diversity and complexity, arise from non-living matter? This question, fundamental to our understanding of the universe, has captivated scientists and philosophers for centuries. While we have uncovered remarkable insights into the origins of life, the complete picture remains shrouded in mystery. Our journey begins approximately 4.5 billion years ago with the formation of Earth. The early Earth was a place of intense volcanic activity, bombarded by asteroids and bathed in harsh radiation from the young sun. The atmosphere was a toxic mix of gases, devoid of the oxygen we breathe today. It was far from an inviting environment for life as we know it. Yet within this chaotic cauldron, the seeds of life were sown. Somewhere amidst the fiery chaos and chemical turmoil, a remarkable transformation occurred. Inanimate matter assembled itself into the intricate molecules that form the basis of all life. This pivotal event, the transition from non-life to life, is a mystery that continues to intrigue and challenge us. The quest to understand our origins is a journey into the heart of what makes us human. It is a search for our place in the grand tapestry of the cosmos. As we delve deeper into the story of life on Earth, we unveil not only the history of our planet, but also the potential for life to exist elsewhere in the vast universe. The early Earth was a world vastly different from the one we inhabit today. Imagine a planet cloaked in a thick, noxious atmosphere, its surface a landscape of molten rock and volcanic eruptions. This was Earth in its infancy, a hot, volatile world bombarded by debris from the early solar system. The relentless bombardment of asteroids and comets delivered both destruction and the building blocks of life, enriching the young planet with water and organic molecules. The atmosphere, a far cry from the life-sustaining mix we know today, was primarily composed of gases like methane, ammonia, and carbon dioxide. Oxygen, essential for most life as we know it, was virtually absent. This early atmosphere played a crucial role in shaping the conditions for life's emergence, providing a chemically rich environment where complex molecules could form. The oceans, still in their formative stages, were hot and acidic. They were a far cry from the serene, life-teeming bodies of water we know today. Yet within these seemingly inhospitable waters, the first chapters of life were written. It was in this hot, mineral-rich environment that the basic building blocks of life, organic molecules, began to assemble into more complex structures. Despite the harsh conditions, early Earth possessed the key ingredients necessary for life to emerge. It had water, a universal solvent essential for all known life. It had carbon, the backbone of all organic molecules, and it had energy, both from the intense heat of the young planet and from the sun's radiation. These ingredients, combined in the crucible of early Earth, set the stage for the emergence of life. The question of how life arose from non-living matter is one of the most fundamental and challenging questions in science. While we don't have a definitive answer, scientists have developed several compelling theories. One prominent theory is the primordial soup hypothesis, which proposes that life originated in a warm pond or shallow sea on early Earth. This soup was rich in organic molecules, the building blocks of life, formed from reactions between the inorganic compounds present in the early atmosphere and oceans. In 1953, a landmark experiment by Stanley Miller and Harold Urey provided support for this hypothesis. They simulated the conditions thought to exist on early Earth in a closed system, including a reducing atmosphere and an ocean. To their astonishment, the experiment produced a variety of amino acids, the building blocks of proteins, demonstrating that the building blocks of life could form under conditions mimicking early Earth. Another intriguing possibility is that life, or at least some of its essential components, arrived on Earth from extraterrestrial sources. This theory, known as panspermia, suggests that organic molecules, or even simple life forms, could have hitched a ride on comets or asteroids that bombarded the early Earth. Evidence supporting this idea comes from the analysis of meteorites, some of which have been found to contain organic molecules, including amino acids. Regardless of how life began, The first life forms were likely simple, single-celled organisms, similar to modern-day bacteria. These early microbes possessed the remarkable ability to self-replicate, passing on their genetic information to their descendants. This ability to replicate and evolve is the defining characteristic of life, and set the stage for the incredible diversity of life we see today. Life as we know it today has a rich and complex history. It all began in the ancient oceans, where simple organisms started to form. Over millions of years, these organisms evolved, adapting to their environment and giving rise to more complex forms of life. One of the most significant turning points in Earth's history was the Cambrian explosion. This event, which occurred around 540 million years ago, saw an unprecedented diversification of life forms. Suddenly, a wide variety of organisms appeared, each with unique adaptations that allowed them to thrive in different environments. Despite our advances in understanding the history of life on Earth, many mysteries remain. For instance, the exact conditions that led to the origin of life are still not fully understood. Scientists continue to explore these questions, hoping to uncover the secrets of our past. As we look to the future, we can't help but wonder about the possibilities that lie ahead. Could life exist elsewhere in the universe? What new forms of life might we discover? The story of life is far from over, and the next chapter is waiting to be written.